Pythagoras Theorem states that the square on the hypotenuse is equal to the sum of the squares on the other two sides. Now first, let's look at the term hypotenuse. The hypotenuse of a right angle triangle is the longest side on a right angle triangle, which is also the side that is opposite the right angle. So if I was to draw a line from the right angle, it would touch the hypotenuse. Now a point to note here is that only a right angle triangle would have an hypotenuse. Therefore, Pythagoras Theorem would only work on a right angle triangle. So on this triangle, the hypotenuse is the side AB, and the other two sides would be BC and AC. So if we apply Pythagoras Theorem, the square on the hypotenuse, so we'll have AB squared, is equal to the sum of the squares on the other two sides. So the other two sides would be BC, and we square that, plus AC, and we square that as well. So what we have is AB squared is equal to BC squared plus AC squared. Now it doesn't matter the order of these two sides. You could have the AC squared first and then the BC squared. Addition is commutative, therefore we can write any one first. So in this question, we have to calculate the value of x. So we have a right angle triangle. We have two sides and one is missing. Now that is how we know when to use Pythagoras Theorem. You would have a right angle triangle. You would have two sides given and one side would be missing. So the first thing I do is identify the hypotenuse. So I draw a line from the right angle to see which side it touches. And this side here at x would be the hypotenuse. So now applying Pythagoras Theorem, the square on the hypotenuse, so that'll be x squared, is equal to the sum of the squares on the other two sides. So that'll be 4 squared plus 3 squared. 4 squared is 4 multiplied by 4, so that will be 16. And 3 squared will be 3 by 3, which is 9. 16 plus 9 is 25. So we'll have x squared is equal to 25. So now we'll take square roots on both sides of the equal sign. And the reason for doing this is that square root and square are the opposites of each other. So that the square root will cancel the square here and we'll get x by itself. And whatever you do to one side of the equal sign, you must do to the other side of the equal sign. So I'll get x is equal to square root of 25 is 5. So x is 5 meters. In mathematics, when you have x squared equal to 25, yes, x would be plus or minus the square root of 25, and the answer will be plus or minus 5. But because we are dealing with the length of a side, we are only taking the positive value, which will be positive 5. So in this question, we have to calculate the value of y. So I have a right angle triangle. I'm given two sides, and I'm missing the length of 1. Therefore, that tells me I have to use Pythagoras Theorem to find the missing side. So I'll draw a line from the right angle, and that will touch the hypotenuse. So the side 5 meters would be the hypotenuse. So Pythagoras Theorem states that the square on the hypotenuse, so that will be 5 squared, is equal to the sum on the squares of the other two sides. So the other two sides is y and 3. So I'll have y squared plus 3 squared. Now notice that in question 1, the hypotenuse was not given, and I started with the hypotenuse first, although it was not given. In question 2, the hypotenuse is given, and I still started with the hypotenuse first. So it doesn't matter whether the hypotenuse is given or not, you always start with the hypotenuse first. The square on the hypotenuse is equal to the sum of the squares on the other two sides. So I'll have 5 squared is 5 by 5, which is 25. I'll write back the y squared, and 3 squared is 3 by 3, which is 9. I'll transfer this positive 9 across the equal sign to the left hand side. Now remember, the sign in front number is part of the number, so this is positive 9. And when it goes across to the left hand side, the sign in front of it will change to the opposite of positive, which is negative. So what I'll have is 25 take away 9 is equal to y squared. So notice the sign in front of the 9 is negative when it crosses the equal sign. Now 25 take away 9 is 16. So I'll write that up here. 16 is equal to y squared. And now I'll take square roots on both sides of the equal sign. So the square root of 16 will give 4. And the square root of y squared, the square root and the square will cancel out each other and you remain with y. So what we have is y would be equal to 4 meters. So in this question, we have to calculate the value of w. So we have a right angle triangle. We have two sides that are given, and we are missing one. and we want to find that missing side. Hence, we'll use Pythagoras Theorem to find our missing side once we have two sides of a right angle triangle and one is missing. So the first thing I'll do is draw a line from the right angle to identify what is the hypotenuse. So the 5-meter line is the hypotenuse. So the square on the hypotenuse, so that's 5 squared, is equal to the sum of the squares on the other two sides. So that'll be w squared plus 4 squared. So 5 by 5 is 25. That's equal to w squared. And 4 by 4 is 16. Now I'll transfer this positive 16 across the equal sign to the left-hand side. And the sign in front of the 16 will change from positive to negative. So I'll have 25 take away 16 is equal to w squared. Now 25 take away 16 is 9. So I'll have 9 is equal to w squared. And now I'll take square roots on both sides of the equal sign. So the square root of 9 will be 3. And the square root of w squared, the square root and the square will cancel out each other and you remain with w. So I'll have 3 is equal to w. So therefore, w is equal to 3 meters. Now an isosceles triangle has two equal sides. So these two sides with the dashes on them means that these two sides are equal in length. And the base angles of an isosceles triangle are equal. And these are the two base angles here that will be equal in size. Now the interesting thing about both an isosceles triangle and an equilateral triangle is that if I were to draw a line straight down the middle, it will split this isosceles triangle into two equal right angle triangles. And the length of this base here would be split in half. So here we can see the isosceles triangle split into two equal right angle triangles and the base split in half. So the distance from here to here is the same as from here to here. And this line here is known as the height of the isosceles triangle. Now in an equilateral triangle, the three sides are equal in length to each other. So we have three equal sides. Hence these dashes signify that the sides are equal to each other. And also the interior angles of an equilateral triangle are equal to each other. So each angle would be 60 degrees. Now likewise, if I draw a line straight down the middle, and this line being the height of the equilateral triangle, I would split the equilateral triangle into two equal right angle triangles. And this base here would be split into two. So the distance from here to here would be same as from here to here. Now this drawing of the height, splitting the triangle into two equal right angle triangles, would only occur when we have an isosceles triangle or an equilateral triangle. The other type of triangle is a scalene triangle, meaning all three sides are of different lengths. And drawing the height on a scalene triangle, you would not get two equal right angle triangles. Now in this question, we are asked to find the area of triangle ABC. So here we have triangle ABC. I'm seeing two dashes on the sides, which will indicate that AB is equal in length to AC, and BC is 6 centimeters here. So AB is 5 centimeters and AC is also 5 centimeters. And we have BC is 6 centimeters down here. Now we know the formula for area of a triangle would be a half base by height, or you could say base by height over 2. So therefore we need to know the length of the height of the triangle. So if you draw a line coming down, which will be the height, we will split this isosceles triangle into two equal right angle triangles. And this side BC will be split into two. So the 6 meters will be split into 3 meters and 3 meters. So what I've done here is I've taken out one of the right angle triangles. So this is the height, as you can see here. This is the side AC 5 meters. So we have AC 5 meters. And here we have half of the base, which is the 3 meters. So first I'll identify the hypotenuse by drawing a line from the right angle. Then I'll apply Pythagoras Theorem by saying the square on the hypotenuse, so that's 5 squared, is equal to the sum on the squares of the other two sides, which will be h squared plus 3 squared. So 5 by 5 is 25, that's 5 squared. Right back the h squared, and 3 by 3 is 9, so 3 squared is 9. I'll transfer the positive 9 across the left-hand side, and the sign in front of it will change from positive to negative. And 25 take away 9 is 16. And now I'll take the square root on both sides of the equal sign. So the square root of 16 is 4. And the square root of h squared, the square and the square root cancel each other and you remain with h. So I'll have the height of triangle ABC is equal to 4 meters. And now remember, the area of triangle ABC is a half base by height, or base by height over 2. So the area of triangle ABC will be base by height over 2. So the base of triangle ABC would be 6 meters, and the height would be this 4 meters here. So you'll have 6 by 4 divided by 2, which should be equal to, we can say 2 into 2, 1, and 2 into 6, 3. And then we can multiply 3 by 4 and get 12. So the answer would be 12 meters squared.